So let's begin the note packet 2.3, which is Reflections Day 2. The objective of today's notes is to continue to use the properties of reflections. And we start with two definitions that we're going to need as we move through the lesson. The first is that of an isosceles trapezoid. So an isosceles trapezoid is a trapezoid in which the base angles are equal and the non-parallel sides lengths are also equal. And then we have a definition of a regular polygon, which is a polygon that is equiangular, meaning all angles are equal, and equilateral, meaning all side lengths are equal. So let's move over to the first problem. We're given that quadrilateral ABCD is a parallelogram. Remember what that means. That means that opposite sides are parallel, so that line DC, upon which line segment DC sits, and line AB are parallel, just as line AD and line CB are parallel. We're told R, S, T, and V are midpoints. So R is the midpoint of AD, S is the midpoint of AB, T is the midpoint of BC, and V is the midpoint of CD. True or false? A reflection across line segment SV carries parallelogram ABCD onto itself. So what is this question really asking? Remember that a reflection that carries a figure onto itself is a line of symmetry. So this is another way of asking, is SV, line or line segment SV, a line of symmetry? Then the question goes on to ask which line would be a line of symmetry? A reflection across which line would carry parallelogram ABCD onto itself? So let's get out a piece of patty paper and let's trace over the parallelogram. In fact, let's trace all the points of the parallelogram over so we can try all the different lines out to see which one is going to give us a line of symmetry. Okay, let me draw the lines in between the points. You should be following along with me and doing this as well. So I'm drawing out the parallelogram. And now I'm also going to draw out all the additional line segments that are present, which are joining midpoint to midpoint here, SV, as well as vertex to vertex over here, BD. Another midpoint to midpoint line segment, RT. And finally, AC. Now, it kind of slipped, but I don't need that anymore because I just have to join these 2 points. Okay, so now armed with this patty paper, let's go ahead and check out the first question. Does SV carry parallelogram ABCD onto itself? Will a reflection across SV do that? So in order to check, let's flip over our patty paper. Let's line up SV to SV. Let's put S on top of S and V on top of V. So S is on top of S, V is on top of V, and no way, right? No way does this take the parallelogram into itself. So SV does not work. So we tried SV. And that doesn't work. We can cross that out. Okay, let's, SV doesn't work. Well, what else do we want to try? So which line? We've got a lot of lines. I think it's pretty clear that any of the lines of the parallelogram itself won't work because AB is going to reflect the parallelogram so that it, whatever it ends up, it's going to end up above line AB. If we reflect across AD, it's going to end up to the left of AD. And BC is going to reflect to the right of BC, and DC is going to reflect under the parallelogram. So none of those can keep the parallelogram in its place. So let's keep looking at some of the diagonals and midpoint connections. So SV didn't work. We've got AC to try. We've got RT to try. And we've got DB to try. So let's try each one of these in turn. Let's try AC. So take back my patty paper. A and C are there. Let me put A on A and C on C. I've got A on A. Whoops, no, this is A, this is C. So there we go. A is on top of A, C is on top of C. And clearly that does not map the polygon, the parallelogram to itself. So AC does not work. You can cross AC out. Next, let's try RT. Let's take our patty paper again. RT is this line that's a horizontal line. Let's see if that works. So let's flip our patty paper over. Let's map our R to R. Let's map our T to T, and that's pretty much it. And I think you can see it doesn't work, right? Because we've got a piece of parallelogram sticking out there, there and there. They don't completely coincide. So RT is history. Let's try DB. That's the last line that might work. Well, let's see how that goes. DB, let me flip this over. Let me reflect over DB. And as you might have guessed, nah, not going to work, right? Basically, we don't have we don't have a mapping onto the parallelogram. We've got point A sitting up here, point C sitting out there, and in our patty paper, C and A are sticking out. So none of the lines work. It's another way of saying that there are none. Okay? None. Okay? There is no line of symmetry in the plane for this parallelogram. Okay. Sort of a trick question, I guess. Let's move on to problem number 2. So now we have ourselves an isosceles trapezoid. E, F, G, H. S and T are midpoints. So we'll refresh our memory. What does it mean that it's isosceles? It means that these two non-parallel sides, FG and EH, are congruent. It also means that the angle GHE is equal to angle HGF, and the same is true for the base angles at the top of the isosceles trapezoid. So let's go ahead and use patty paper and try to answer the question here, true or false. A reflection across EG carries the isosceles trapezoid onto itself. Let's see if that's true or not. The way we're going to do that is by, again, tracing the trapezoid. We've got S, we've got T, E, and H. Please, also you should follow along with me in doing this. Okay, did I get F and G? Are those the right labels for those points? I want to be absolutely sure. Yep, F and G. Okay, good. So now I'm going to connect the lines. And and oops, kind of slipped, but it almost doesn't matter at this point because I've got all the important landmark points. So I can just connect the dots at this point. We've got that, and then I've got these two diagonals, EG, and HF, and then ST. Okay, hopefully you are finished also with this. And now let's test it. A reflection across EG means we've got to flip over our patty paper, and we've got to line up EG with E and G. So let's try to line up E and G with E and G. And we see it does not work. Okay, that is not going to work at all. Got a piece of trapezoid sticking out on top, and on the bottom, definitely not working. So it's false. Okay, and gee, I didn't circle up here false as well. This is false. The question is, a reflection across which line would carry the isosceles triangle into itself? So let's try to figure out which line looks like a line of symmetry. And I think after we've done some of the work with letters, you kind of have more of an intuition, and I'd say it looks like ST, right? Because it looks like E is to the left of S about the same distance that F is to the right of S, and H is to the left of T about the same distance that G is to the right of T. So let's try ST. So we've got trapezoid there. Let's flip it over. Let's put S on S and T on T, because remember, points that are along the axis of symmetry do not move. They stay stationary. And I think you'll see this looks very good. Okay, this looks very, very good. As we flip this back and forth, you'll see it goes right on top, and it superimposes very nicely. So the answer is line ST. Okay, so line ST would be the line that would carry the isosceles trapezoid onto itself.